A very good afternoon, everyone. Welcome to week 4 of this semester, and I hope that all of you are doing very well. And I also hope that you're keeping up with all the assessments and all the studies that you have been assigned with in all different courses. So, with CIN535, I again welcome you to Multimedia and Communications. Now, for week 4, we had certain amount of tasks in our to-do list that we should be able to complete by the end of the week. So we have a lecture class, which we will be going over just within a few minutes. Moreover, you are to attend all your lecture-based quiz. Do know that lecture-based quiz, it carries certain percentage towards your coursework. Most likely it carries about 1.5 to 1.75% towards your coursework. Moreover, we have a Zoom-based lab class, which is tomorrow in the morning from 9 to 11 a.m. And also, please begin working with your projects. Now, moreover, do know that as per our assignments layout, you have a short test one, which is supposed to be held in week 5, that is next week. Now, short test one is already up on Moodle. And this particular short test will open up on the 22nd of August. That means on Sunday. 22nd of August is on Sunday. Yes, it's on Sunday. So it opens up on Sunday, 6 a.m. in the morning, and it closes up on the following Sunday, 29th of August, and it closes at 11:59 p.m. There are 20 multiple choice questions, and you are allocated 1.5 minutes per question, with a total of 30 minutes for the entire short test. Now, do note the following: you are provided with only one attempt, which means once you attempt it, it's gone. Okay, so for that, you need to ensure that you prepare yourself very, very well. You are allocated 30 minutes to attempt the short test. Ensure to time yourself well with each question. Now, since it is a multiple choice question, you are given only 1.5 minutes per question, a total of 90 seconds. Now, please, as I mentioned previously, prepare well before you go around attempting the quiz. Now, question and answer review will be provided after the closing date and time. That means where you've gone wrong, where you've gone right, what is your mark, you will be provided with that after the 29th of August and after 11:59 p.m. And finally, all the very best. Now, the coverage is all the way from week 1 till week 4. So you are tested basically and mostly on your theory and some of or very slightly from your lab classes. So very basic steps from there. So that's on your short test one. For your project, it has already been released up on Moodle. It's due on the 10th of September. So you have close to about 3 weeks from now to actually attempt your project one, which is based on the topic surrealism, and it carries 20% towards your coursework. So please ensure that you do not waste away time. Try to attempt it as soon as possible and submit it to your earliest. So we are going to week 4 of our Moodle section. Okay, week 1, week 2, and week 3, they all have their weekly lecture-based quiz. Please do attempt them. Out of the total of 14 students in the class, we have close to about only 3 or 4 of you who have just attempted your lecture-based quizzes, while others are waiting for what, which I'm not so sure. Or are you waiting for the 31st of October? Please do not drag on to these quizzes. If you leave week 1 quiz for the 31st of October, you'll end up dragging all the lecture-based quizzes. So please try to attempt it at the end of the week. If you are well versed with the syllabus, it should not take you less than 10 to 15 minutes to actually attempt the quiz. It's just 10 questions anyway. All right. So week 4, we'll be going over lecture 4. Now, lecture 4 is basically based on and is a continuation from lecture 3. So not much slides over there, 20 plus slides. So we will be able to finish that within an hour. After the lecture quiz, we will go over the lab exercise, which we had left in last week's class. So these are the ones. We'll try to go our very best to complete it within the class time, so that tomorrow we are actually able to attempt all these exercises. So these are for tomorrow. So without further ado, let's get on with our lecture 4. Okay, so lecture 4, like mentioned earlier, it is a continuation of lecture 3. Now in lecture 3, what we're viewing, we were actually looking at the types of images. By now you should be knowing that there are two major types of images. We have raster images or bitmap images, or we have vector images, or sometimes they're called as drawing based images. Now, both these images have certain advantages and certain disadvantages. Please know what are the advantages and disadvantages of them. Now, when you talk about raster or bitmap images, normally raster images are 2D based images. Now, vector images, they can be either 2D or 3D. So this particular week, we will be talking about 3D images. Now, 3D drawing. So last week we said 2D drawings are basically X and Y axis on the Cartesian plane. And while 3D would be X, Y, and Z axis on the Cartesian plane. That means you're seeing everything in 3D dimensions rather. Now, when you're working with 3D, it takes a lot of skill and talent. Creating 3D dimensional objects is not easy for designers. In fact, it is very, very difficult. Now, designers who are mostly comfortable working with squares, circles, any other 2D geometrics, they are the ones who normally find it a bit difficult to work with 3D images. So to work with 3D images or to work with 3D kind of drawings, you need to use special 3D animation tools, and there are many of them. Examples of some tools may be Autodesk by Myers, or by another common example is Google Sketchmap. You have Autodesk Inventor and many more. Now, 3D tools, generally, they are not available for free. You have to pay for the licensing of it, or you might have to pay for its general subscription. Some of the common places where 3D applications are used, okay, features of 3D application where they're used, they're generally used in architectural drawings. If you've had a look at a house plan, okay, if you haven't, just go up to Google and type down a house plan, and then you'll see various 3D architectures. Moreover, 3Ds are used in complex and realistic designs. So when we talk about realistic designs, something that looks real, something that is real, and when you try to come up with such designs, it's difficult, okay, it's complex. So that's why it's known as complex or realistic designs. And finally, we have panoramas. Now, panoramas, you might have this feature in your mobile phones, in your cameras. Okay, so what happens is with panorama, you take a wide angle view or a representation of a physical space. So you have a physical space, the surrounding, so you're able to take a wide angle view that you are not able to generally take with one specific shot of an image. For example, when you are taking a panoramic image, what you do is generally you are able to, you have to rotate your phone to a certain level of 180 degrees to 260 degrees. Only then it captures the entire wide view of a surrounding. So that's panorama. 3D animation drawing and rendering tools. So these are some of the common tools. Okay, so you have Dash 3D, you have FormZ, you have Mutex Lightwave, Autodesk's Maya, you have Google's SketchUp. So what these particular applications do is generally they allow you to create 3D images or 3D animations. Now, these images that you see here, okay, you have 4 different sketches. Now, they all show different things. So if you look at this, the one that I'm circling up, this one and the one above of it, what you'll notice is basically it demonstrates image in a 2D dimension or 2-dimension. But if you look at the right side, the very same image has been demonstrated in a 3D method. So that's how it is. Now, if you look at the image which is shown here at the bottom, this shows an example of living Okay, and what you see on this side is what you see an example of extrusion. Now, what lathing and extrusion are, we will be looking at it in the next few slides. Features of 3D application: modeling, where you are placing all the elements into a 3D space. So when you talk about modeling, it's just about you coming up with a model. Okay, model, that means a representation of something that may be real. Extrusion, the shape of a plane surface extends some distance. Now, extrusion, basically, we have shapes that extend some distance, either perpendicular to the shape's outline or along a path. Okay, so what it simply means is you are showing a specific shape in different angles. For example, what you see here, okay, this is a 2D. In 3D, this is an example of extrusion whereby you are seeing the shape in different specific angles. Extrusion. Lathing, a profile of shape is rotated around a defined axis. In other words, lathing is whereby you are trying to create a 3D object and you are showing what it looks like in a rotated view. Generally, it's animated. For instance, you have this particular image, and let's say your shape, it's moving. Now it's moving all around from up to down and left to right. Now you must have seen this somewhere. You have a specific object which is being rotated and you're able to see all the different angles in it. Now this is an example of what we call it as lathing. Now with extrusion, the shape remains still. With lathing, it is moving. Rendering, use of intricate algorithms to apply user-specific effects. Rendering is when a computer finally uses some intricate algorithms to apply the effects you have specified on the objects you have created. In other words, what happens is you are applying some effects on a specific shape. Rendering can also be used in videos or in images as well. You have applied some specific effects on the original image, let's say, and to actually process it, it goes to a rendering process. Remember last week we were trying something out in uh, what what examples that we did last week? Remember we were doing something like context aware. Okay, so when we had filled in we had removed a specific object, it took time for the image to actually show up or show the final product. Now that is an example of rendering. When you apply an effect, so what happens, the algorithms on the background of the specific software is trying to apply those effects that you have just fixed in. So that's an example of rendering. Panoramas. Panoramic images are created by stitching together a sequence of photos around a circle and adjusting them into a single seamless bitmap. This is what I was telling you earlier. Okay, to make this work, one needs to stitch things together. Now, what it simply means is many images, they're taken from different angles around a circle or semicircle, and finally, all those images, they are combined into a single seamless image. When we say single seamless bitmap or single seamless image, it's just like you are taking a single shot. It will seem something similar as that, but in fact, it is not. It's different shots stitched together. Try doing the same thing in your phones probably. If you have I'm not so sure if second phones, I think the latest A series they have it rather with the camera. If you go to more features, you have the panorama effect, whereby what you do is you take a certain shots of the surrounding and the camera will basically notify you or direct you to move the phone into different angles. So once you're moving it, it will take image shots, plenty image shots, not one or two, many, and then it will try to stitch it together. So while you're rotating your phone's camera is taking images, is taking photos, and then finally it will stitch it together. So that's an example of panorama. Color palettes, colors and palettes in multimedia. Understanding nature, light, and color. Light comes from an atom where an electron passes from a higher to a lower energy level. Okay, now that's quantum theory. If we have done physics, that's what quantum theory is about. Okay, lights come from an atom when an electron passes from a higher to a lower energy level. Okay, that's what quantum theory is about. Each atom produces uniquely specific colors. Color is the frequency of a light wave within the narrow band of the electromagnetic spectrum to which the human eye responds. Now, overall, like I mentioned, whatever we have talked about, those 3 points, that is the quantum theory. Okay, how light actually functions. So light generally they come from molecular atoms, and each and every atom it produces some form of a specific color, and that color depends on the levels of energy that is thrown into that atom. Higher energy or lower energy level have different colors. Okay, another way in which we have or we demonstrate colors is through the use of mnemonics. Mnemonics are MNEMONIC. Okay, so with mnemonics what we do is basically we represent certain colors. For example, you have ROYGBIV, that's the mnemonic for the rainbow colors, whereby R stands for red, O stands for orange, Y is yellow, G is green, B is blue, I is indigo, and V is violet. So these mnemonic values represent the colors of rainbow. Now that's generally, again, that's also defined from the quantum theory. Now do not get too confused with it, or do not think how will I write these things in the exam. Now these things are hardly tested in exams. It's just for the purpose of you knowing how nature, light and color comes through. All right, now we must also know this is that now generally there are lights which is in form of infrared. Now, when we talk about infrared, it simply means it's not perceived by human eye. For example, some of the devices are, or some of the devices, they actually have infrared lights in them, and we humans, we do not see those color of the lights. For example, if you look at your television remote sensors or the remotes, okay, so they have infrared light. So you must have noticed, right? At the very top of the television remotes. So if you want to increase the volume, so you have to point that infrared light sensor towards the TV. So your TV is basically at a receiving end and the remote is a transmission end. So as it receives those infrared lights, it is able to have some form of electronic diodes sent over, and then it performs some specific commands such as increasing the volume or decreasing the volume. So that's where we say sometimes some lights are in the form of infrared. That means we are not able to perceive it, or we are not able to see it with our human eyes. Now, infrared light is basically generated through the form of radiated heat. In other words, these infrared lights, they come from heat signatures. And also there's another type of light which you call it as ultraviolet light. Now ultraviolet light are beyond higher end of the visible spectrum. What it simply means is that those lights are on way more higher energy end than the normal color of the lights that we generally see. Okay, and these lights can be damaging to the human. Example, radiation. Now, there are certain devices which emits certain level of radiation. For instance, your mobile phones give out certain form of radiation. Now, what part of your mobile phones does that is basically the screen part. Your computing devices, your laptops, your computer screens, they also emit certain form of radiation. And these are in the form of ultraviolet lights. So these radiations are harmful to our body. Now, sometimes you may say, people would say, okay, do not stick around in your phone for long. It causes damages to the cells of your eyes. Now, that's true. If you would stick around too much to your phones, okay, especially to the screens, and also if it's on a brighter set mode of light, then generally it will cause damage to their eye. Nowadays, we have mobile phones which are coming in, which have blue light sensors. So what happens is you can activate the blue light, and the blue light, what it will do is instead of throwing white bright light, it will show a bluish, or it will throw a bluish light from your mobile phone screens, which causes way less damage to your eye. Another way in which you can counter this is by wearing specs or glasses which are multi-coded. Now, what are multi-coding then? So multi-coding glasses are lenses within your eyeglasses which are able to defeat out the ultraviolet or damaging rays from light from certain specific devices. For instance, if I am wearing a eyeglass and if my eyeglasses lens is multi-coded, so if I continuously use computer screens, if I continuously use mobile phones, it might cause less of damage to my eye compared to what it will do without a multi-coded eyeglass. Okay, so that's the difference. Now sometimes you'll see people, they are wearing eyeglasses, and as soon as they go out into the sun, it changes into a shadowish color, or it changes dark into color. Now that's not multi-coding. That's what we call it as transition lens. Multi-coding is specifically used for computer screens. So if you are making your eyeglasses, if you want to have your lens multi-coded, it may cost you another $150 to $200 to actually get it done. Here in Fiji, in overseas countries, it may be cheaper. Okay, for example, if you look at countries like India, it's cheaper. Even US and Australia is way more cheaper. While in some countries like UK is very expensive. Depends how well your eye is able to adjust to those lenses. So that's on understanding nature light and nature color. Now things to note from here: light, how does it form? It forms through the use of atom. Now color, okay, what it does, it comes through a electromagnetic spectrum, okay, and our human eye responds differently to it. Now you have two forms of light, infrared and ultraviolet. Now infrared light, three forms of light, sorry. The one that's normal, the natural light that we're able to see, and then you have infrared light, which generally our human eyes cannot see, and we have ultraviolet light, those light which may be damaging to our human body and human cells. Understanding nature light and color continued. So there are four types of colors. We have additive color, you have subtractive color, you have monitor specific color, and then you have color models. Now all these colors, we use them in different devices in many different ways. Additive color. In the additive color method, a color is created by combining colored light sources in three primary colors: red, green, and blue, or in short form, we call it as RGB. Now, TV and computer monitors use this method. So, additive color, whereby the three primary sources of light is through three different colors: red, green, and blue. And where are these used? These are generally used in CRT monitors. CRT is cathode ray tube. Now, the olden days computer monitors that we had, the big bulky ones, those are CRT monitors. Now, you also must have seen televisions which used to be very similar to those cathode ray tube monitors, the big bulky televisions. So they have a tube within it which actually throws light. So cathode ray tube. We have LCD monitors which generally use additive color as well. So that means combination of red, green, and blue. And then you have plasma displays which also use additive color. By the way, the long form for LCD is liquid crystal display. Subtractive color. In the subtractive color method, color is created by combining colored media such as paints or ink. The colored media absorb or subtract some part of the color spectrum of light and reflect the others back to the eye. So with subtractive color is basically created by combining colored media, example paints or inks. It absorbs part of the color spectrum, it reflects the others back to the eye, and it is used mostly in creating color in forms of painting. So when you're doing something for, not painting, sorry, printing. So when you are doing some form of printing, let's say on a paper, or let's say in a calendar or something like that, you are mostly using subtractive colors. So the primary colors in subtractive color are CMYK, okay, whereby C stands for cyan, M stands for magenta, yellow, the Y is yellow, and K would stand for black. Now, in subtractive colors, we have CMYK, cyan, magenta, yellow, and black. But generally, we do not find black as a color. Now, black is not considered as a color because it's most likely an absence of any color. So, three primary colors again, cyan, magenta, and yellow are in subtractive colors. Yeah, okay, it's given here in the next slide. Monitor specific colors. Colors should be used according to the target audience's monitor specification. The preferred monitor resolution is 800 by 600 pixels. The preferred color depth is 32-bit. So with monitor specific colors, our eyes receptors are sensitive to red, green, and blue light. So by adjusting the combination of the colors, our eyes and brain will interpolate the combination of these colors in between. What happens is our eyes, they are sensitive to taking in direct green, direct red, and direct blue light. So if you directly look into a room, or if you are in a room which has a direct red bulb in it, and the room is completely red, you won't find it easy to look around. In fact, you'll find it very painful to your eye. So what happens is that by adjusting the combination of red, green, and blue, okay, our eye and brain interpolate the combination of these colors in between. So when we see change, a combination of these color incur. For example, if you look at the palettes over here in Macintosh, Windows, and website, what you'll notice is that all these colors that you are seeing is basically a combination of red, green, and blue. So with monitor specific colors, so different variations of red, green, and blue represent different colors, and that is much more pleasing to our eyes and to our brains. And the very last type of color that we have is model specific colors. Models used to specify color in computer terms. Now, RGB model, a 24-bit methodology, color is specified in terms of green, red, and blue values ranging from 0 to 255. HSB and HSL models, color is specified as an angle from 0 to 360 degrees on a color wheel. Other models include CMYK, CIE, YIG, YUB, and YCC. Now, what we understand from here, or what I would like you to understand, is there are different models of colors that are used in computing devices. So the common ones that we generally use is RGB, and then we have HSB and HSL. Now RGB, we've already understood, is basically the combination of red, green, and blue. Now HSB and HSL are those colors which are represented in the form of hexadecimal numbers. So when we say hexadecimal numbers, example, if we want to display a pure green color, is represented in the hexadecimal serial node called #00FF00. So these are hexadecimals. Now, how does it represent the color? Again, it's represented from the combination of red, green, and blue. Color palettes. These are mathematical tables that define the color of pixels displayed on the screen. Palettes are called color lookup tables or CLUTs on the Macintosh. The most common palettes are 1, 4, 8, 16, and 24-bit deep. Now, the simple way I can make you understand what a color palette is basically, remember when we were working on Photoshop? So if you want to go around changing the color of a particular text or color of a particular object in the image, so what you do is you would go to your foreground color and click on it. It displays your set of tables. So Those set of tiny square table of colors are called palettes. I think we just had it in the slide here. See, these are examples of color palettes. So they represent certain combination of colors. For example, if you look at this particular color, which is orangish, okay, so that's an orange color palette. The whole thing is called a palette. So one of those boxes represent different colors. So that's the simple way I could tell you what color palette is. Dithering. Dithering is a process whereby the color value of each pixel is changed to the closest matching color value in the target palette. This is done using a mathematical algorithm. Now, what happens in dithering? Dithering, it is a process whereby 24-bit, for example, let's say a 24-bit scan image, an image is scanned is 24-bit. So what happens is when you scan it, and if you want to reduce it to 8-bit color, so what you can do is you can get the best replication of the original image by dithering the colors of the image. Now what it simply means is this: I scan a copy of a particular image and I want to have it in my computer. Now what I want to do is, or what my computer would try to do is, it will try to represent the best possible color that I have scanned. So what it will do is it will perform a dithering process. So by dithering it, what it will do is the computer will try to detect what specific color that scanned image is. For example, if it is a version of green, so it will try to look at the very best and the nearest version of the green and then try to represent in that particular scan image. So that is dithering. So if you would read the definition once again, is a process it's a process whereby the color value of each pixel is changed to the closest matching color value in the target palette. Okay, and how it is done? It is done through the use of mathematical algorithm. Now, image file types used in multimedia. So we have different types of image file types in Macintosh. You have Windows, and then you have cross-platform formats. Now, Macintosh is Apple-based, Windows is Microsoft-based cross-platform. That means they can be used in either of these two formats. So when you look at on the Macintosh, the most commonly used format is PICT. Okay, for example, just like in Windows we have .jpeg, it's PICT. Okay, so PICT is a complicated and a versatile format developed by Apple. Almost every image application on the Macintosh can import or export PICT files. In a PICT file, both vector-drawn objects and bitmaps can reside side by side. Now, what to take away from here is the common type of file format that you have in Apple Macintosh computers is PICT, P-I-C-T file formats. In Windows, the most commonly used image file format on Windows is DIB, also known as BMP. When we say DIB, it's device independent bitmap. Okay, it's also known as BMP. So bitmap formats used mostly by Windows developers are. Now, here's the thing: when we say Windows format, so if you look at the original operating system image files, they are generally stored in such formats: BMP, TIFF, and PCX. Okay, JPEG and all those formats, those are cross-platform formats. Yeah, cross-platform formats, JPEG, GIF, PNG. That means they can be used in any of the operating systems. Adobe PDF, it also manages multimedia content. Now, you must know is when you're using Photoshop, you can always go and save your image in PDF format. Okay, so that's a cross-platform. It can be used in Microsoft Windows or in Apple Macintosh as well. And then you have PSD, that means Photoshop document. You have AI, Adobe Illustrator, CDR, and DXF, proprietary formats used by applications. So these are specific formats which can be used by specific types of formats. CDR is Corel Draw. Okay. Initial Graphic Exchange Standard, or IGS or IGES, standard for transferring CAD drawings. CAD is computer aided design drawings. Don't worry about that. Just know this. Okay, in window formats, DIB or BMP are the common formats. Cross-platform, JPEG, GIF, PNG. Okay, and you have Adobe PDF as well, which could be used as a cross-platform formats for images. Now, summary. The computer generates still images as bitmaps and vector-drawn images. Images can be incorporated in multimedia using clip art or bitmap software or by capturing, editing, or scanning images. Creating 3D involves modeling, extruding, layering, shading, and rendering. Color is one of the most vital components of multimedia. Now, why color is one of the vital components? It gives life to images, it gives life to multimedia. So compare this, you have a billboard which is black and white in color, and you have a billboard which is colorful. So which one do you prefer? Obviously the one which has colors. Now, some lecture-based questions. This is for you to try it on your own. So do try answering them. You never know, some of these questions might appear in your short tests. Also, the eye test master questions, the previous lectures, you never know where they might be tested. Discuss the difference between bitmap and vector graphic. Okay, and describe 5 different graphic elements you might use in a project. For example, the background, buttons, icons, or text. Would you use a vector tool or a bitmap tool for each element? Why? Question number 2, you're assigned to create an interface that will look across platforms. What is the difference between images as shown on a Macintosh and PC? And how would you deal with such kind of problems? Try answering them, okay? And in your own time, on your own, or if you want, you can use a discussion forums which are given on the weekly sections of the Moodle shell, and you can communicate with one another. And that finishes up our lecture. Now, we are able to finish this within 35 to 40 minutes. I did mention it, this is quite small because it's a continuation from the last week's lecture. Now, this lecture is a bit confusing because it uses a lot of technical elements. Should you need to read more on it, now I have inserted some additional readings on the lecture note sections, okay? But still you'll find it difficult to understand because these are very, very technical elements. Now, from this set of lecture 4, you should understand is, okay, the importance of light and the importance of colors in images, understand what are 3D drawings and some of the basic features of 3D. Moreover, the 4 different types of lights, try to learn the difference between them. Additive, subtractive, you have monitor specific color and color models, and also what are the different types of image file types in Macintosh, in Windows, and on cross-platform, cross-media platforms. Okay, try to know the different types of file types. So that finishes up with the lecture notes. Now, what I will do next is basically, I'll request all of you on your screens to open up photop.com, or if you want, you can just have a look and then you can try it on your own. I'll go around and I'll mark week 3 exercise. This will take me close to about another 30 to 40 minutes to mark it. So first one you'll see is, now I will download them. Actually I already have them downloaded in my computer. So I will open up photop.com, and then from here I will start editing those images. So first one is change the color of the strawberries. Okay, so what you'll notice is that you have strawberries. Now it's not spread over the image, it is on certain portion of the image. So I have to go around changing the color of these. Now what I can do is I can change this into a different color, and I can go around changing the strawberries which are on that particular bowl in different color as well. So it all depends how the selection process is done, and it all depends on you, how do you want to go around changing the color. So let's go and attempt this first. So what I'll do is I will do it, okay, and then you can also try attempting on your own. Now, first of all, how would I go and select this portion? So what I will do is I will quickly go and select my quick selection tool, and from there, I hope you're able to see the cursor. Yeah, this is where it is, and I will go and place a click on it. So when I place a click on that particular reddish color, what you'll see, it also picks up color outside the image. Now I can quickly go and adjust that. And to adjust it, so once you have already selected the quick selection tool, you have your options menu. So from the options menu, I will click on the subtract option, and then I will try to select the portions that I have selected outside strawberry. Okay, don't worry if it goes inside, I'll adjust it just in a while. Now at the moment, what you'll notice is that I am only picking up portions within the frame of that strawberry, nothing outside it. So if I have to select the edges, now you'll notice once I place a click on it, so I'll go back to unite option, it again jumps outside. This means this tool is of no further help to me. So what will I do then? Now, what I can do is this. I will go select my lasso tool, okay, make this bigger in size so I can pick up the edges, and I am selecting the edges and creating a circle. Pardon me, it needs to be under unite option. And I have selected the edges of the strawberry. Now what you notice is some bit of this is also not selected, so I will cover up this element from here to there and make a circle and unite it up. Likewise, portion of it is not selected, and there you go. Now have a look at this. So from the edges, I'll go down, select all the unselected version of that particular strawberry, and that is selected. I'll pan towards the right hand side, and again I will select that. There's a bit of edge which is not selected here also, so I will make an effort to ensure that is selected. Here some more portion missed out. Now what you'll notice is that I am creating a circle. So why I'm creating a circle? Because where my start point is, my end point is at the same place. So the starting point and the ending point, they are supposed to meet. So I have selected the strawberry. So once I've selected this, from here, I can go on to my new adjustment layer. I'm supposed to change the color. So I'll go and click on hue or saturation. So the range that I'm picking is red, and I want to put it into a dark blue color, for instance. So I will drag it to the left-hand side. So why do I drag it to the left-hand side? If you look at the color guide, dark blue is somewhere over here. So that means this hue bar needs to come in line with it. So there you go. So this is how you go around changing the color of your strawberry. Now you have selected this. To deselect, Control and D, that allows you to deselect. I'll minimize the image. This is how it looks. Now it doesn't look in any particular way that I have manually edited the color of it. It looks real, does it? It does. Okay, now next up, let's go and change the color of these strawberries. Now these need to be on different color. Let's choose a color, probably pinkish or probably light purplish, and try it out. So if you notice, my layer is on the adjustment layer. I have to select the background layer, and from here I will go to my quick selection tool from the tools menu. I've selected it, and then now here comes a problem. pardon me. So what the problem is this, when I try to select the color, okay, it tries selecting the entire image. So what I will do is I'll press Control D, deselect it, and then I'll try to drag. No, it doesn't allow me to select using the quick selection tool. So if it doesn't allow, that's fine. Let's try a different tool. Okay, now let's try it one more time. So on quick selection, I will decrease the size of my, now it selects the entire thing all over. Okay, so what other tools can we use? Now this is very common. You can always have problems in terms of selection. So what other tool would allow me to do so? So quick selection tool doesn't allow me to do that. Would lasso tool allow me to do that? Probably. Let's try with it. Okay, so lasso tool is whereby you can pick up the edges. So I can do that. So very quickly, I'll try to select all the edges of the fruits. Now I want all of them to be selected all together, not one strawberry at a time, but all of them at once. So what I can do is I will run the edges on all of it. Okay, now portion of my image is hidden, don't worry about it. Okay, run across the edges, do not try to select between portions, but run outside it. There you go, there you go. Okay, and you go a bit further towards the right. Now white portion is selected, don't worry about it, we can readjust that even later. And I'll need to go and select all of this. So how do I do that? Okay, so this is what I'm doing using my lasso tool. I've selected it. Now let's pen my image to the left hand side. Okay, now this is what I can do next. I will maximize this. Now I don't want to have this green portions selected. So in the options bar, look at subtract. Okay, and I will go and deselect first of those greens. So that is deselected. Make it bigger so that it becomes easy for you to select. Okay, so this is the edge, and I will have to select all of this. Okay, and on this range, so here's my meeting point. So what you'll notice is I have deselected it. Also portion of green is still remaining. So to have it selected as well, now I can do this, or also subtract these portions. Okay, now you have that working there. So we have deselected this. There's also a portion of green here as well. So these need to be subtracted from the entire selection. There you go. Where else do we need to deselect? Here, this portion. So I'll pen it towards the left hand side, and then I will select it to deselect. Likewise, have these deselected. Very well. Let's move on to the other portions. Now, what you notice is this runs out and away from the edge, so I can always go and subtract this. Also notice somewhere here, you have selected some white portions as well. So I will zoom in and then deselect these portions. Move over, select to deselect. All right. Now, next up, what all is left? Now, what all you'll see is left is here, this red portion on the very left hand side, this, I will need to go and select it. So what do I do? So for my options bar, I have a unite option. So zoom in, all right. So zoom in. So from here, I've just pressed Ctrl Z to go back to the previous stage. and I'm starting it all over. So zoom in very slowly, make a circle. Okay, so that portion is selected. Likewise, zoom in a bit more to have it all selected. Remember one thing with Photoshop, it takes time. Also, you need to have a bit of patience, a bit more than patience, and you'll see what you'll see here is a little bit of red. So we'll try to color this up as well, or select that portion as well. So there you go. Okay, now we have generally selected the strawberries. Now we need to go and change the color. So how do we go around changing the color? New adjustment layer, hue or saturation. Let's go and pick a color, probably light blue or green. So select the reds. From there, hue or saturation. You can have it in blue or green. I'll choose it in greenish. So once I have that, let's go and see if things look well. It does. Control D to deselect and zoom out. This is how you go around changing the color of those strawberries. Looks good? Any questions, any queries? All right, so this is how you're going to change the color. Simple or difficult? Izal, simple or difficult?
Simple.
Simple. Okay, it just takes time. Okay, likewise other participants who have joined us in the class, it's very simple, but what it does, it requires a bit of time and it requires a bit of patience. Okay, otherwise this is pretty simple, just simple few steps. Okay, moving on. The next thing that we had to do was, or the next image that we were working on was, we had to go around cloning the beetle. Okay, now do notice is that cloning, we generally use a clone stem tool, which you have here, but in this case I don't think that using the clone stem tool is going to be very easy. Why? Notice this. So if I use a clone stem tool, normally I would go and make the size of my brush bigger, as big as you can or as small as you can. So hold button, place a click, and then you can create that particular object and clone it. But in this case, what you'll notice is that when you try to clone it, it basically distorts that particular flower. So using a clone stem tool is not one of the best options in this case. Okay, so what I will do next is this. So since using the clone stem tool is not the best option, so I will go and undo this. After that, I will go and use my lasso tool. So using the lasso tool would be one of the best option. Now, why using the lasso tool is going to be one of the best options is, what you can do is you can select the entire of the beetle and then you can copy and paste. So that will basically do the same job. So I will spin it to the right hand side and ensure that I'm able to see the entire of that particular beetle, so that it will make it easy for me to select using the lasso tool. So I will perform a selection now. So very carefully and very slowly, I can go around. Now remember this, the point where I have started, that's the place where I will need to stop. So that's a long way around, like I mentioned, bit of patience and bit of time consumption. So I will go all around. As slow as you can. The more slow you are, the more accurate it would be. At the moment, I'm going way too fast. Generally, I would prefer to go way more slower than this. Okay, now be very careful on the edges. Okay, now notice this. Either I can cover up the red portion, or either I can go and outline the legs. So I will go and outline the legs and then cover up the other remaining parts. So if it's zoomed in properly, you should be able to get the edges of them very, very easily. Now, with zooming in, another advantage is that when you are zooming in an image, if you extract some portions which are outside the outline of that specific image, when you zoom out or make it smaller, the outside portions would not matter much because you have selected the pixels at a zoomed in stage. Okay, now what I've done is I've selected the entire beetle. So I'll press Ctrl C to copy and Ctrl V to paste. So what you notice is that you had background image together with it. You have a new layer popping in. But where did the image go? Where did this beetle go? So the beetle is directly on top of it. So I will zoom out and then pull this and place it somewhere over here. Just moved, pardon me. There you go. What I can do is I can place it somewhere over here probably, or here. Up to you, anywhere that you want to. So that is how you go around cloning the beetle. Any questions, anyone? Now we can go around refining the edges even more by blurring it, but let's just stick it to what we have at the moment. Let's keep it simple. Okay, if no questions, let's move on. The next one is we have to remove the window using our spot healing brush. Okay, now even though you use your spot healing brush, this might distort your image to a certain bit. I think I did mention it last week. Okay, never mind, we're just trying to make sure, and we're just trying to learn how to use the spot healing brush. So for the purpose of that, it should be fine. So your spot healing brush is this specific tool on the left hand side. So what you'll do is you'll very carefully select it, and then spot healing brush is not like our lasso tool selection tool. You cannot click and drag. It's just a spot. That means one click only. So let's say if I want to remove these and this window, two of those, so I have to perform it one at a time. So I will have to make sure that my brush tool is bigger. Now, also notice if your brush tool, if you have options to make it in square, you can do that. For example, here, okay, this demonstrates square values. So if you want to have it in the form of squares, it doesn't allow you to do so. Or does it? Oh yeah, it does allow you to do so. Okay. However, okay, let's try using squares. Let's see how does it look. When you click on it once, give it some time. Now this is the rendering process. I've applied the effect. You have some mathematical calculations running in the background, and it tries to remove that, and it is removed. And do notice this, if you zoom in, you'll see that it damages the pixels. Okay, so the pixels, they have been damaged a bit, this bit distorted. What I mentioned earlier on was, don't worry about it. Okay, we are just trying to learn the use of spot healing brush. So again, we'll give it a try using spot healing brush. So I will try to make the size of the brush a bit smaller. I'm using the shortcut key, pardon me. So I'm using the shortcut key, which is the open rectangular bracket. to make it smaller and open the colon bracket to make it bigger. So this is the adequate size. Click on it once. And the rendering process. So what is rendering? It allows the computer to run some mathematical algorithms on the background to adjust to the effect that I have just applied. And there you go. And if you would minimize this, this is what and how the image looks like. So that's the example, or that's the exercise on remove the windows using spot healing brush tool. Next exercise is on, let's read this. You have taken a perfect picture, you've taken a perfect shot, and this lady ruined your pic. Remove her from the image. So you want to have, you have taken a perfect picture with the sea, mountains, and a pathway. However, this lady comes in somewhere in the middle. So what you want to do is you want to remove her from the image. Now, there's two things to note. First of all, you have to remember which specific tool to use. So the right specific tool to use here is you have to use a selection tool to first of all select her, and then you have to use a content aware tool or content aware feature or effect, whatever you like to call it as. Okay, so I will use my lasso tool. Now with using content aware, you need to ensure you have to leave some space between the object. At the moment the object is this lady, the object and the background. Okay, so leave some space between it so that the effect could be applied properly. So I am making a selection right on the edges of that particular object. In this case, it is this specific lady. And then I will have to ensure where I started, it comes the midpoint. Selected. From there, edit command, and then fill. Now fill, you have to choose content aware. Now here's the thing. Sometimes what results you would like, it would not come up. Okay, you may not get the expected results. So if you do not get it, do not get disheartened, but try some other technique. That's how we apply different types of tools on Photoshop. We do a bit of trial and error. I click on OK and see what effect does it come to. So Control D to deselect. Now, what looks off? Do notice this looks off because you have half of a it's a bin, it's a rubbish bin or a vase, I cannot make out, and also you have shadow. So you will need to go and edit these as well. Now, with the rubbish bin, more likely it's a rubbish bin. Okay, I'll again use the lasso tool, make a border all around. So I need to ensure when I am selecting it, I have a bit of background selected as well, and then edit, fill, content aware. Okay, Control D. Now that looks better now. Do notice you have a shadow. You cannot have a shadow without object. So let's go and remove this. This is going to be catchy. Why it's going to be tricky or catchy is because you have to select it in a way whereby it does not make it look too obvious that something is removed. So right on the edges, very, very carefully, I select it, edit, fill, content aware. Okay. And if I would go and zoom out, looks good. So you have removed the lady, the perfect shot of the mountains, the ocean is very much visible. At the moment, what you'll see is you'll feel that if you look somewhere over here, it feels like you've just removed something. Okay, but think of something like that in terms of, let's say you never knew that there was a lady here and you removed it. So what you said, this image is edited? I doubt that. You will hardly realize, or you'll hardly say that this particular image was edited. It looks way more realistic. Okay, so this is how you use your content-aware tools to remove that object, in this case, that lady, from that image. Any questions, any queries, anyone? Any questions, any queries?
All good, sir.
Okay, thank you. If no questions and no queries, this is all that we had for today. We have discussed our lecture 4, and also we have gone around discussing our lab. So if you have any questions in regards to the lab in tomorrow's lab class, you're most welcome to ask. In tomorrow's lab class, what we will be doing is on the week 4 section of the Moodle shell, we will try to combine all the features we've learned so far with some additional features that you will learn tomorrow, and then we'll edit those images. Okay, so we have 9 images, so we'll work on, not 9, we have 10 images, so we'll work on 10 of those. Till then, everyone, take care, stay safe. Thank you so much for putting in your time and effort to join us today. Thank you.
Thank you, sir.
Thank you.